Understanding the photoelectric effect. The photoelectric effect is a phenomenon in which electrons are emitted from a material when it is exposed to light. This effect plays a crucial role in our understanding of the behavior of light and matter. Let's explore the key points of the photoelectric effect and how it was explained by Albert Einstein in 1905. 1. Threshold frequency. Electrons are only emitted from a material when the frequency of the incident light is above a certain threshold frequency. Below this threshold frequency, no electrons are emitted, regardless of the intensity of the light. This threshold frequency is a characteristic property of the material and depends on its composition. 2. Intensity dependence. If the frequency of the incident light is above the threshold frequency, the intensity of the light governs how many electrons are emitted. Higher intensity light leads to a greater number of emitted electrons, while lower intensity light results in fewer emitted electrons. This relationship between intensity and electron emission is a fundamental aspect of the photoelectric effect. 3. Maximum kinetic energy. The maximum kinetic energy of emitted electrons is independent of the intensity of the incident light but is proportional to the frequency of the light. This means that increasing the intensity of the light does not increase the maximum kinetic energy of the emitted electrons. However, increasing the frequency of the light results in higher maximum kinetic energies for the emitted electrons. 4. Einstein's explanation. In 1905, Albert Einstein proposed a revolutionary explanation for the photoelectric effect. He suggested that light could be thought of as made up of discrete particles, now known as photons, with energy proportional to their frequency. This idea was inspired by Max Planck's work on black body radiation, where he introduced the concept of quantized energy levels. According to Einstein's theory, the energy E of a photon is given by the equation E equals hf, where h is Planck's constant and f is the frequency of the light. This equation suggests that the energy of a photon is directly proportional to its frequency, with h serving as the proportionality constant. Using this concept, Einstein derived an equation for the maximum kinetic energy K max of emitted electrons in the photoelectric effect. The equation is K max equals hf minus phi, where h is Planck's constant, f is the frequency of the incident light, and phi is the work function of the material, which represents the minimum energy required to remove an electron from the material. Conclusion. In summary, the photoelectric effect is a phenomenon where electrons are emitted from a material when exposed to light. This emission depends on the frequency of the light, with electrons being emitted only if the frequency is above a certain threshold. The intensity of the light affects the number of emitted electrons, while the maximum kinetic energy of the emitted electrons is determined by the frequency of the light. Albert Einstein's explanation of the photoelectric effect is the result of light consisting of discrete particles, or photons, with energy proportional to their frequency, revolutionized our understanding of light and laid the groundwork for the development of quantum mechanics.